In October 2025, an image began circulating online. It appeared to show a missing boy from South Australia being lifted into a car. Within hours, thousands shared it, hoping to help, desperate for it to be real, but the picture wasn't a photograph at all. It had been generated by artificial intelligence and posted without context, turning a family's real grief into a digital illusion. Still images have always carried authority. A single frame feels like proof, frozen evidence of something that happened. That's why synthetic pictures travel so fast. They borrow our instinct to trust what we see. They don't need to fool your logic, they only have to reach your emotions first. I'm Sef Homen, an artist and journalist studying visuality. Today, I'm going to show you how to detect whether an image you see online is fake. Human vision evolved for survival. Among all senses, sight gave the fastest and most reliable information about danger, food, and emotion. Evolutionary neuroscience describes vision as a sense with a great benefit-to-cost ratio. The brain learned to trust what it sees, because that trust once meant staying alive. In modern media, that instinct still drives perception. When the eye meets a realistic image, the brain builds an internal simulation of the scene. Studies show that lifelike motion and depth cues activate emotional and motor regions, the same circuits used for real-world experience. The effect is automatic, it feels genuine before we analyze it. Artificial intelligence systems exploit this reflex. They reproduce the patterns that make a scene appear natural, lighting that mimics sunlight, camera shake that suggests authenticity, micro-movements that resemble human expression. These cues create realism without evidence. Research shows that perceptual realism and authenticity can dissociate. A realistic face or gesture can trigger empathy and memory even when no real person exists. The brain often responds to familiarity more than to fact. Familiarity acts as a shortcut. Experiments in visual cognition show that we recognize familiar faces or symbols faster and with more confidence, even when the image is incomplete or distorted. Synthetic videos use that bias. By reproducing familiar imperfections, they appear more believable. Media psychology work warns that this process reshapes public trust. Synthetic visuals borrow the emotional language of truth, motion, expression, lighting, to influence attention and belief. Griffith University research and commentary from Stanford's JSK program describes this as a growing form of cognitive manipulation, where realism can disconnect from reality. Every synthetic video carries traces of how it was made. Digital forensics specialists describe these traces as subtle violations of how bodies, light, and texture behave in the real world, signals that a clip was generated, not filmed. Real movement follows physical rules. Muscles shift weight, joints limit motion, and gravity grounds every gesture. AI systems still struggle to preserve that logic. Fingers may fuse or bend unnaturally, ears drift between frames, teeth blur as a head turns, movements can appear to float, hands gliding too smoothly, faces rotating faster than shoulders. These artifacts arise because many generative models synthesize frames with weak temporal coherence rather than capturing motion as one continuous structure. Light in authentic footage obeys physics. It travels in one direction, softens across surfaces, and changes color with the environment. Synthetic videos often break that pattern. Shadows flip sides, reflections vanish, highlights remain fixed, while a head moves. When illumination disagrees with motion, the illusion collapses. Surface patterns and text expose similar flaws. AI can imitate soft light and skin tone, but still stumbles on geometry. Fabric folds may repeat exactly, wallpaper patterns drift mid-wall, printed words blur into nonsense when paused. These breakdowns reveal how diffusion models approximate form instead of understanding it. Real footage also carries biological rhythm, tiny color changes from pulse and breath, subtle texture variations across time. Deepfake smooths those out, producing airbrushed skin and frictionless motion. Engineers detect such absences by measuring micro-fluctuations in light and compression between frames. Viewers often sense something wrong before they can explain it. The brain notices when gravity feels off, when blinking mistimes speech, or when reflections move independently of the scene. That intuition is data. Forensic experts translate it into measurable proof. Each anomaly, warped anatomy, misplaced light, repeated texture, missing rhythm, forms a fingerprint of generation. Digital forensics converts those fingerprints into evidence. Learning to see them is the first step toward visual literacy in a world where realism no longer guarantees reality. Every digital image or video carries a hidden record of its life. data that quietly describes how, when, and with what it was created. Investigators call this metadata, a technical fingerprint that can confirm authenticity or expose manipulation. Metadata often contains details such as the recording device, creation time, GPS location, and modification history. Forensic analysts read these fields to reconstruct a file's story, much like investigators rebuilding a timeline from physical evidence. When the camera model, date, and geolocation agree with the claimed narrative, a file gains credibility. When they don't, the mismatches can reveal fabrication. This process is known as digital provenance analysis, tracing a file's path from capture to publication. Experts at Tower Forensics and Capsicum Group show how metadata reconstruction authenticates digital records, verifying internal timelines of creation, modification, and upload. The same logic applies in journalism, where provenance checks determine whether a viral image or clip truly originated where it claims to. AI-generated or heavily edited media often disrupts this pattern. Synthetic files may include empty, contradictory, or fabricated metadata. Fields that should list a camera might read unknown device. Timestamps may conflict, suggesting re-encoding by multiple systems. Eclipse Forensics calls this the metadata void, a digital silence that signals fabrication. Authentic material, in contrast, typically leaves a coherent trail even after later edits. Metadata can also mislead by omission. Some software inserts generic entries to imitate real camera data, while others erase traces of editing altogether. Moreover, major social platforms routinely strip metadata to conserve space or protect privacy, making verification harder. That is why investigators emphasize context: who first posted the file, when it appeared, and whether the same image exists elsewhere online. If the timeline, uploader, and metadata disagree, the inconsistency itself becomes evidence. Analysts use specialized tools to reveal these hidden fingerprints. EXIF tool, Metadata to Go, Camera Forensics, and Forensically can display embedded data such as software used, compression history, GPS coordinates, and the number of saves or exports. Proven data describes metadata as the backbone of digital forensics, connecting a file to its real-world origin. Authenticity usually leaves traces, manipulation often leaves gaps. Comparing a file's metadata with its accompanying story helps determine whether an image or video documents reality or imitates it. In an environment where synthetic media spreads faster than fact checks, metadata remains one of the few verifiable witnesses left. When a photo or video surfaces online, its story can often be tested by looking backward. Reverse image search is one of the most accessible and reliable verification tools for that task. It reveals where else the same visuals have appeared, showing whether they document a genuine event or recycle older content. Reverse search works by analyzing the visual fingerprint of a frame, its colors, textures, and edges, and comparing those signatures across vast image databases. Unlike captions or metadata, which can be falsified or missing, this process relies on the structure of the pixels themselves. The algorithm recognizes persistent geometric and chromatic relationships, even when a picture has been cropped, resized, or filtered. This approach has become a cornerstone of modern visual forensics. Academic and OSINT research confirm that these structural features remain stable across most basic editing operations, making reverse search effective even when details are partially altered. The technique detects both exact duplicates and visually similar derivatives, allowing investigators to trace a file's lineage, what analysts call visual provenance. To use it, pause a video and capture a clear frame, a skyline, a face, a vehicle, or a distinctive background. Drag that frame into Google Images or T9. Each platform compares it against billions of indexed visuals and returns similar results, revealing when and where the image first appeared online. If the same picture predates the claimed event, the story is being recycled. If no match appears, that absence can also be telling. Synthetic or AI-generated images often have no history in the web's visual memory. For video, specialized tools such as InVid-V-Verify and Amnesty International's Digital Verification Corpse toolkit automatically split footage into keyframes, each searchable on its own. Matching even one element, a building, a license plate, a symbol, can expose a clip that has been repurposed or mislabeled. Studies in newsroom practice show that combining frame-level searches with provenance checks greatly increases accuracy in detecting manipulated or recontextualized media. Leading investigative teams rely on this workflow daily. Bellingcat's OSINT researchers use multiple reverse search engines in parallel to cross-check findings and map misinformation networks. The New York Times Visual Investigations team applies the same process to verify breaking news footage, confirming location, date, and sequence across platforms. Reverse image search technology continues to evolve. Newer algorithms employ AI to detect partial or composite matches, identifying deepfake frames or hybrid scenes that share only fragments with known images. Emerging provenance systems now automate the process, continuously scanning multiple engines to track where synthetic content begins to spread. Reverse search remains the simplest and most powerful first step in visual verification. It demands no specialized training, only curiosity and skepticism. When the same picture carries different captions, the story has changed. Looking backward is how truth-checking begins. Some traces of manipulation remain invisible to the naked eye, which makes forensic and AI detection tools vital for uncovering synthetic media. Every AI-generated image or video carries a subtle fingerprint, microscopic patterns embedded in its pixel structure, noise profile, and compression artifacts. Much like a painter's brushstroke, each generative model leaves statistical traces that differ from those produced by a physical camera. These include irregularities in color distribution, spatial frequency, and pixel correlation that no optical sensor would naturally create. Work from Binghamton University, MIT, CSAIL, and UC Berkeley shows that algorithms examining pixel-level noise residuals can reliably separate authentic from synthetic material. Real photographs contain random sensor noise reflecting camera physics, while AI-generated imagery displays uniform, algorithmic patterns typical of GEM or diffusion synthesis. Modern forensic platforms and other academic or commercial detectors use large reference datasets of known AI outputs. Through neural networks and frequency domain analysis, they identify anomalies in texture continuity, lighting gradients, and edge coherence that the human eye may overlook. Some advanced prototypes can sometimes attribute an image to a specific engine, for instance Midjourney, DALL-E, or Stable Diffusion, by decoding recurring model-specific statistical features. However, attribution remains an emerging research area rather than a guaranteed capability. Deepfake detection algorithms go beyond single frames, analyzing physiological and temporal signals, microexpressions, eye movement, and pulse-related color shifts visible across sequential frames. When these cues disappear or fall out of sync, systems flag the clip as synthetic. Studies from Tongji University, Brunel University, and PMC's 2025 review on biometric and temporal anomalies confirm the value of these cross-frame measurements, which expose manipulations that static image tests might miss. The same field now includes digital watermarking and content provenance, cryptographic tags embedded at capture to build a verifiable chain of trust from source to publication. Standards from the Coalition for Content Provenance and Authenticity and Adobe's Content Authenticity Initiative make automated authenticity checks possible. Media lacking valid provenance records can be flagged as unverified. Detection remains an arms race between generation and verification. Each new AI model forces forensic tools to evolve, but these systems still provide critical transparency. They decode invisible fingerprints, pixels instead of ink, that reveal how synthetic media are made. Every generator leaves a signature written in data. Forensic analysis translates that signature into evidence, giving journalists, researchers, and investigators a way to expose fabricated visuals hidden in plain sight. Invisible fingerprinting is becoming one of the foundations of accountability in the AI media era. Technology can reveal manipulation, but only context reveals meaning. Contextual verification anchors truth in logic, history, and human intention rather than pixels alone. Studies from the Reuters Institute and the University of Amsterdam confirm that visual recontextualization using authentic visuals with misleading captions or timeframes is now one of the most common forms of online visual misinformation. The image may be real, but the story around it often isn't. Real footage can be repurposed to create a false narrative, deceiving without fabricating. One of the clearest examples appeared in March 2022, when a deepfake video of President Volodymyr Zelensky surfaced online, appearing to show him ordering Ukrainian troops to surrender. The podium, lighting, and voice seemed convincing, but fact-checkers quickly spotted inconsistencies. The head-to-body proportions were off, shadows didn't align, and lip movements lagged behind audio. Zelensky released an authentic statement hours later, exposing the clip as a synthetic fake, a deliberate act of wartime disinformation meant to damage morale. Nearly 2 years later, the pattern repeated. In November 2023, another fabricated video circulated, falsely claiming that Zelensky had ordered troops to abandon Avdiivka. VoxCheck traced the material to AI-altered footage and a synthetic voice, again designed to exploit public trust in video realism. Contextual verification begins with 3 guiding questions. Who posted it? When was it uploaded? Who benefits from its spread? These questions move the focus from pixels to intent, the story behind the image. Real-world physics, geography, and verifiable authorship give authentic content structure. Fabricated narratives tend to collapse under logical scrutiny, revealing impossible locations, contradictory environmental cues, or anonymous and unverifiable publication chains. Credible journalism produces the opposite pattern: clear timestamps, bylines, verified geolocation, and corroborating sources. Misinformation thrives on opacity, circulating through anonymous channels, meme networks, and repost loops where origin becomes unknowable. Researchers note that emotional manipulation is central to the tactic. Outrage, fear, and empathy accelerate sharing and suppress skepticism. That is why fact-checkers at the BBC Poynter Institute recommend a deliberate pause, a brief moment of reflection to disrupt the effective trigger when emotion overrides reasoning. Context is where digital forensics meets human judgment. Verification is not about how real something looks, but whether its story holds up under light, logic, and time. Real evidence aligns with the physical and social world. Fabricated stories demand that audiences stop questioning. Context restores that questioning, reminding us that truth depends on coherence and accountability. AI doesn't care about consent, context, or consequences, but you can. Artificial intelligence now fabricates images, voices, and entire narratives with no inherent concern for truth or accountability. Its disregard for consent, context, and consequence shifts responsibility onto human vigilance. No single test can prove authenticity on its own. A reverse image search may yield nothing, metadata can be stripped or forged, and forensics can sometimes remain inconclusive. But when these layers, visual observation, technical analysis, and contextual reasoning are combined, patterns begin to emerge. Together, they rebuild trust in the media ecosystem engineered to confuse. Experts at Binghamton University describe this struggle as an arms race of pattern and counter-pattern. AI generators evolve to erase their own fingerprints, while forensic systems adapt to uncover new ones. The goal is not absolute certainty but continuous vigilance, keeping humans central to verification. As BBC Future notes, technology can expose inconsistencies, but only human judgment can interpret them. Verification is no longer passive viewing, it is a form of investigation built on patience, skepticism, and curiosity. This mindset begins with slowing down before reacting, asking whether content fits what you already know, and testing if its story holds up under logic and time. In the digital age, truth is not self-evident, it is constructed through sustained attention and the willingness to question. That vigilance extends beyond visuals. AI now replicates human voices, behaviors, and identities, enabling large-scale fraud and influence operations that exploit emotional and cognitive trust. Real-world incidents show deepfake voices used in multi-million-dollar scams, bypassing traditional verification systems. New forensic tools, including real-time detection and investigative AI assistants, help identify such manipulations by mapping relationships across large datasets and flagging hidden correlations. Yet technology alone cannot replace the nuanced human judgment required to interpret motive, credibility, and ethical consequence. Every synthetic generator leaves a signature written in data. Forensic methods can reveal those traces, but only informed human discernment can judge their meaning. That is why visual literacy, the ability to question what you see, is as crucial as any detection algorithm. Training people not just to look, but to see, turns verification from a technical exercise into a civic skill. The most effective defense against AI-driven deception lies in an engaged, attentive public, people equipped with both the tools and the mindset to verify truth through a layered, iterative process. Permanent vigilance is the cost of clarity in the AI arms race. Technology can help expose what is false, but only human attention can preserve what is true. The story starts with a photo, a missing child captured in a moment that felt urgent and real. The image spread fast, shared by people who wanted to help, convinced they were seeing the truth. But the boy in the picture wasn't there. The scene had been generated by artificial intelligence, pixels arranged to imitate pain, not documented. That's the world we live in now, one where code can manufacture emotion and urgency on demand, where realism no longer guarantees reality. But seeing through it doesn't require perfect tools or expert systems. It begins with slowing down, asking questions, and thinking like a detective. Look at the light, the framing, the source, the motive. Truth hides in the details machines still fail to imitate: consistency, coherence, and intent. The technology that blurs fact and fiction isn't disappearing, but awareness changes everything. Each pause, each verification, each act of questioning keeps the real visible amid the artificial. The more people who learn to see critically, the harder it becomes for falsehoods to pass as truth. All sources are in the description. Check them out if you want to dig deeper.